Hello, everybody. My name is Adrian Torres, and I'm from FarLab León. And today I want to talk about the ATtiny1614 and the programming form with Linux or Mac with the UPDI. First of all, I'm going to share my desktop. And today I use my documentation about the Adrianino. It's a new little board with the ATtiny1614. And in this web page, I documented all the steps to create the Adrianino and the dataset of the ATtiny1614 and the different characteristics about this microcontroller. And today I'm going to talk about the programming with UPDI. Okay. This is the operation. And first of all, I'm going to install the Arduino IDE, okay, and use the expense content tutorial. In this web page, you can read all the parts of the UPDI programming. This link, the installation here. You need to copy this URL and open an Arduino IDE. And in Arduino, I click in preference and paste the URL I copy in the board manager. It's the same. Okay, and it's important the compilation. Then in tools, we choose the boards and we use the ATtiny1614. You need to update the boards manager and search the ATtiny1614, okay? And we continue with the instructions about install Pyupdi. You need to download Pyupdi in this web page. You need to download. Okay. And then you need to open a terminal and you copy this in the terminal and paste and install the pip3. Okay. And then you can connect the FTDI to detect I change my camera because we have the FTDI with the FTDI 230X, and with this FTDI we can connect the converter of the serial to UPDI. Okay. First, we connect the FTDI, and then we need to discover what type of FTDI we have connected. I share my desktop again. And in the terminal, we put testmeg. and we connect and disconnect, and we know the type of FTDI are connected. This is our FTDI. Okay. The name of the on the port name. Then we start a little program in Arduino. In my case, I use an example is the blink, because in the Adrianino we have a little LED, and we can change the speed of this LED. This LED is connected in the 8, okay. And we need to change here is the 8, here 8, here 8. We need to use this ATtiny1614 with this voltage, and then the clock speed is internal, and we detect the FTDI if is the FTDI USB 0, and we use the admelize UPDI programmer. And then we need to compile this Arduino program. When you compile, it's finished. You need to search this file to upload this hexadecimal file to the ATtiny1614. Okay. In my case, this is in a temporal file, and we need to search here. Just a moment. Temporal Arduino. Okay. And we have this file. Okay. Another thing we need to new screen. We download the Pyupdi. You need to decompress this tip, and we have these files of the Pyupdi master. Okay, and here we need to copy the X file and paste in this Pyupdi master file. Sorry, you need to replace. Okay, it's here, the blink. And then we need to use the terminal, and here we compile, we look the X file, we paste it in the Pyupdi folder, and then in the terminal go to the Pyupdi, the Pyupdi master file, and then we connect the FTDI, the serial to UPDI convert, the module. In my case, I use I use this module because in this module we have a UPDI, GND, and power supply, and we connect to the FTDI cable and connect to the board. And I share the screen. And then we program the board using this command. It's sudo python 3 pyupdi ATtiny1614. In the cases we use the ATtiny4012, you need to change this. This make more bigger. Paste. And I paste the instruction, and in this case I use the speed, and this is the name of the file to upload, and go intro. And then I upload all the program, and I stop sharing the screen, and you can see the blink of the ATtiny1614. Okay, I change my camera and share my desktop. Sometimes you can have problems to upload the program, and you can see different messages, but it's normal to upload the program. You can read a lot of lines of code. And in my webpage of Adrianino, you can show a lot of examples of inputs, output devices, and I think it's very easy for everybody. I think to create this board for people who has very scared about the electronics, and it's very easy to use this new microcontroller. And finally, you can see here all the sensor I tested. Just a moment here. All the sensors on the LCD with I2C, or the output devices. And finally, I tested with a PCB prototype. This is all. Thank you so much. Bye-bye.